Hello everyone, this is the fourth video about machine learning and model evaluation, and in this video we will learn about clustering. Well, let's begin. The evaluation of the clusters resulted from a clustering algorithm is a not easy task since there are no true labels to compare with the clusters. The evaluation can be divided in two categories, internal and external. Internal measures the quality using the training data. External uses the external data test set. However, the external evaluation is not completely accurate as compared to the methods for supervised learning. Silhouette coefficient is an internal metric to measure the quality of the build clusters. It is a popular method that combines both cohesion and separation. The silhouette coefficient for an individual object, example or data point, can be computed as follows. First, given an example, calculate its average distance to the other example. Well, so do this. We take this point, this top right corner point, for an example, and we will calculate we will measure the distance of that point for the other points in this cluster. Well, we measure this distance of this to this, to this, to this, to this, to this, and to this, and we will calculate the average of this distance. Second, do the same using the other clusters. After calculate average of this cluster, the distance of this point to the other point in this cluster, we will calculate the distance of this point from the close cluster of this cluster, that is this cluster. Well, we will calculate the distance, measure the distance of this point to this, to this, to this, to this, to this, and the other and the all points on this cluster, and we will reach the average of this. Third, the silhouette coefficient for this point is B represent the distance of this point from the other cluster, how it showed in this step B, and A the average of these measures. We will subtract A from B and divide it by the max value, B or A. If A is the max, we will use the A. If B is the max, we will use the B. The coefficient can be evaluated between -1 and 1. A negative value of this formula is not desirable since it indicates that the average distance of AE to its cluster is greater than to the other clusters. On the other hand, a positive value of this formula is an ideal value, and if the result is equal to 1, indicates that the average distance of all points in this cluster is 0. Rand index Ri is a metric for external evaluation. It compares the predicted clusters to the real clusters, manually assigned by an expert user or a human. And it is similar to accuracy metric for supervised algorithms. Here is how to calculate Ri. Let X be a dataset. CP, cluster predicted, be a clustering set of clusters built by the cluster algorithm, the machine predicted, and CR, clustering real, be a set of ground truth values, ground truth cluster, sorry, are clusters manually assigned by an expert user. 2. True positive is the number of examples, data points, belonging to the same cluster in clustering predicted and clustering real. 3. True negative is the number of example data points belonging to different clusters in clustering predicted and clustering real. 4. False positive is the number of examples data points belonging to a cluster in clustering predicted but to a different cluster in clustering real. 5. False negative is the number of examples data points belonging to a different cluster in clustering predicted but the same cluster in clustering real. 6. Rand index is calculated as follows: true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. We remark that Ri is calculated exactly as accuracy. Metrics are essential tools to evaluate a machine learning system. Each one must be carefully studied to understand the behavior of the build model. Some metrics can be affected by noise in the data, aka outliers, and others may smooth the effects of noise.